Hey everyone, so today we're going to be doing factoring and some throwbacks to Algebra 1 as well as some new factoring for Algebra 2. So the first thing I want to say is you should always be looking for a greatest common factor. So no matter what, that's the first thing we're going to do. I wanted to show you a couple here. This one does not have a greatest common factor, but just to remind you kind of that generic trinomial where a is equal to 1. There's a couple ways you can set this up. Some people draw like a diamond, what multiplies to 30 and adds to negative 13. You definitely don't need to draw this diamond, just as a heads up, that is something people do. And that would have to be negative 10 and negative 3. Okay, so then we put those in parentheses, x minus 10, x minus 3. Hopefully that one is familiar to you. Remember, you could FOIL to check it. Okay, let's move on here. So again, first thing I'm looking for is a GCF. I look here, they all share a 3. And they also all share an x squared. So that's the first thing we're going to do. Take out the 3x squared to the front. And remember, really what you're doing here is dividing each one by 3x squared. So let's see what we have left. X squared minus 6x plus 8. Okay, my recommendation is whatever you have in your parentheses, keep checking. Is there anything else I can do here? What multiplies to 8 and adds to negative 6? That would be negative 4 and negative 2. So again, wanted to start out with some of those where GCF and then a is equal to 1 here, kind of some easier trinomials. All right, let's move on to what if we have 4 terms? 4 terms, we're going to use grouping. Okay, grouping is when we make 2 groups and we're going to look for the GCF in each group. So this first group, my GCF would be 3a. And what do I have left? I have c and then plus 1. Okay, I should put a symbol here, either plus or minus, just whatever is here. So I'm just going to put a plus sign. And my GCF for my second group is b. And so I also have c plus 1. All right, so what you're going to do to finish up this problem is we bring these together. Our GCFs become 1 parentheses. Okay, and c plus 1 comes together as our second parentheses. So this is our final answer. Notice the parentheses are touching, multiplied. That means they're factored. Okay, if we were to leave it like this is not factored because there's still a plus sign in the middle of these terms. So again, kind of what you're doing is almost like undistributing the c plus 1. That's why there's only 1 in the final answer. All right, and a second one here. Let's see what we got. Make 2 groups. We look for the GCF in the first group, which is 8z x minus 1. Okay, and in the second group, be careful here, guys. We want it to be x minus 1, so we're going to have to take out a negative 4w, so that this becomes x minus 1. And again, bring those together. Okay, hopefully you know I made a little bit of a cardinal mistake here, which is I didn't check if there was a GCF at the beginning. This is a good learning experience, right? Notice all of these have a 4, okay? The good thing is right now I can go look and be like, wait, this parentheses is not fully factored. Since there's a 4 in it, I do have to take it out. And now I'm fully factored. So to check your work at the end, there's not really a totally way to check if you're totally factored because this would also be the same answer as this. But you do want to check if each parentheses is fully factored. There's no GCFs. There's nothing else you can do, no difference of squares or anything like that. So speaking of difference of squares, let's talk about those. So your kind of classic difference of squares is perfect square minus a perfect square, and we get a minus b, a plus b. Okay, so if we're going to look at these next examples, we'll start off with an easy one here, x squared minus 9. It's almost like you're taking the square root of each. You have x and 3, and I put those into our parentheses, x plus 3, x minus 3. And again, the reason this works is because we're multiplying 3x and negative 3x, and those middle terms will end up canceling out. So we'll just end up with x squared minus 9. All right, so let's try a little bit of a tougher one here. Okay, we see a perfect square minus a perfect square, despite being a little more complicated looking. And again, what you want to start with is trying to find that square root. So 25x to the fourth y squared. That would be 5x squared y. And then we would have 6z to the third. So from here, what we want to do is take those two pieces and again, place them in parentheses where I'm adding them together and subtracting them. 5x squared y minus 6z cubed. Okay, two kind of special ones left here. 16x to the fourth minus 81. Again, my hope is that you recognize it's perfect squares. And we try simplifying here. So we get 4x squared minus 9, 4x squared plus 9. Again, 4x squared and 9 are our two square roots. Now, I want you to think from here, can I continue? Okay, well, take a look right here. 4x squared minus 9 is actually another difference of squares. So we're going to end up continuing here, guys. 4x squared minus 9 is 2x minus 3 and 2x plus 3. Okay, can we continue with 4x squared plus 9? No, because it's not the difference of squares, it's the sum of squares. So 4x squared plus 9, and this would be our final answer right here. 2x plus 3, 2x minus 3, and 4x squared plus 9 does not continue. And again, you can try making up two parentheses that would multiply to 4x squared plus 9, but there are none that will work. Even if you tried both positive, you'll get 4x squared plus 6x plus 6x plus 9, and they'll not end up canceling. Okay, so 4x squared plus 25, look for a GCF. No, it's two terms. So can we do difference of squares? No. So this is what we call prime. So again, when we can't factor something, we don't really say no solution since there's no equal sign. We call that prime. Okay, so I want to move on to the factoring trinomials where a is not equal to 1. Okay, so these are some important ones here, and definitely up to you on how you want to solve these. So I want to make clear that I'm going to show you a couple methods. You definitely can pick what you want. And you could also just do guess and check if that's what you grew up doing. So take a look at the first one here. So again, guess and check would just be like this. You try out maybe 2x and 2x, what multiplies to 3. You know, you plug in 1 and 3. You see if it works. I mean, that's what guess and check is. So I'm not going to spend time on that since literally it's guessing and checking. But what I want to spend time on is this method I call divide and slide. Okay, and again, you do not have to use this, just an idea for you. So the first thing you would do is multiply 4 times negative 3. So I moved that 4 to the other side. It looks a little weird. It's technically different, but we're just going to use it as kind of a shortcut to get to that final answer. So then we're thinking what multiplies to negative 12 and adds to 11. That would be x plus 12 and x minus 1. Okay, now notice, this is where the mistake comes up. People like to leave the answer like this, but is this the same as 4x squared? No, right? So we have to do one little thing. Again, this is called divide and slide. So we're going to divide by what we multiplied by. So this 4 is coming back into play. Divide by 4. If we can simplify, we do. So x plus 3. This one does not simplify. So if we can't divide, we slide. And we move that to the front. And we're done. Okay, so that is one method you could pick. So for 2x squared plus 11x plus 15, I'm going to show you a different method here. So we'll do split the middle. You might have learned that in junior high or last year or the year before that. So let's take a look here. Okay, so split the middle. Really, you kind of just use this diamond if you need. You say, what's 2 times 15, or a times c? That would be 30. Okay, and what adds to 11? This would be 6 and 5. Okay, so what you end up doing, you end up splitting that middle term, and you use 6x and 5x. Okay, so notice I didn't actually change anything about the problem, right? 11x is still 6 plus 5, but I split the middle in a certain way. Okay, and now what we're going to get to do is factor by grouping, which we talked about earlier. So I look for that GCF. I look for the GCF in the second one. It's going to be 5. Okay, I have matching parentheses, yay, and I can bring these terms together. 2x plus 5 times x plus 3. All right, guys. So the last one we're going to try, again, pause if you need to, pick what method you like between these two. That's usually, or just do guess and check, whatever you've done prior to this. Those are the two I typically talk about. Look at this one. We have m squared, n squared, and mn. All that really means is that we're going to have a couple more variables in our answer. Okay, and whenever you see this double variable situation, I really recommend doing split the middle. So let's do that again. So what multiplies to 2 times negative 3, a times c. This is a, b, and c. And what adds to b, or what adds to negative 5? This would be negative 6 and positive 1. Okay, so for this one, again, we're splitting the middle. So I have 2m squared. And notice that I have mn as my variable here. So I'm going to have to use these two terms, negative 6 and 1. And I'm going to do negative 6mn plus 1mn minus 3n squared. And I really want you guys to focus. Negative 5 is still right there. Negative 6 plus 1. All I did was just split it in a certain way. Okay, and then I'm going to do my little grouping. So I've got 2m times m minus 3n plus, this would be n times m minus 3n. Lots of same sounding letters there. Okay, m minus 3n works. Those are both there. So I've got 2m plus n and then m minus 3n. So just notice how it became a little bit different at the end due to the fact it had m as your first variable and n as a second variable. So this might happen, and we're okay with that. All right, so last two things I want to talk about, perfect squared trinomials. Okay, we're going to talk briefly about these. They're not super important that you have to memorize them, but it is kind of a nice trick to know if you see them. So perfect squared trinomials, okay, for example, if I said what multiplies to 64 and adds to 16, you would say 8 and 8. So you can either write it like this, or you could write it as x plus 8 squared. Okay, and a perfect square trinomial just means you end up in that format, a plus b squared or a minus b squared. Okay, now why am I showing you this? Well, I will warn you, something like this is a little more annoying, right? Because do I want to do 16 times 25? Not really. Okay, so one thing you can look out for is if you start and end with a perfect square and you find those square roots, okay, you can tell if this is going to fit into this, because if a is 4x, so this is 4x squared, this is 5 squared, then the middle should be negative 2 times a times b. And negative 8x times 5 is negative 40x. So this does fit into the pattern. So that's one way you can check if it fits into the pattern. And that being said, now we would just use this sign. Okay, 4x minus 5 squared. It would be a minus b squared. Now, if you don't like this, again, you can kind of do any method you want, and we can talk more about it tomorrow. So again, just a hint there as to looking for patterns when you have perfect squares in a trinomial. All right, so let's move on to our final thing here, guys. Stay with me. We've got sum and difference of perfect cubes, and I definitely want to talk about this since it is new. Okay, so prior to this, if you had two terms, such as like a squared minus b squared, the only thing we knew were difference of squares or GCF. So now we just have one new thing, which is when I have two perfect cubes added or two perfect cubes subtracted. Notice that they work for both. So not one of them is prime, both are correct, or both are factorable, excuse me. So a cubed plus b cubed, basically what we're going to do, we're going to find those cube roots, a and b. We're going to have a parentheses where we have a plus b, and then a squared minus ab plus b squared. The only difference over here, guys, are those signs. So notice I have minus plus plus. Okay, this is where this word SOAP is going to come in. We use the same sign, the opposite sign, and the last sign is always positive. Okay, so take a second to write that down. Same sign, opposite sign, always positive. Okay, so from here, we've got a plus to start. So I have same sign, opposite is minus, always positive is plus. So let's try that again. I started with a negative, so that would be Same sign, opposite sign, always positive. Okay, so let's try this out below here. So x cubed plus 27y cubed, both perfect cubes. And if you even want to write it this way, you could say, what's the cube roots? It would be x and 3y. So it's almost like you're doing this. Okay, so we're going to take those guys, we're going to put them in a parenthesis. We're going to use the same sign, that's this. Then we're going to square the first term, opposite sign. The next part coming up, guys, is AB, meaning just multiply these together. So I'd get 3xy. Always positive. And we square the second term, 9y squared. And that's it. The second trinomial will never factor, so don't worry about trying to factor that. Okay, let's try one more, guys, and we'll practice more of these in class. So 216, a to the 6th, b to the 3rd, minus c to the 6th. So again, the first thing you want to figure out is, and I guess I'll call them x and y here because we're already using a and b. What are the two cube roots? Well, 216 is 6 cubed. I have a squared b. And again, really, here's what you're doing. And then cube root of c to the 6th would just be c squared. So here are my two cube roots. Let's plug them in. So again, you do the first cube root, same sign, so minus c squared, times the first term the first term squared, which would be 36 a to the 4th b squared. Again, I'm doing this squared. Okay, opposite sign. Multiply these together, 6a squared bc squared. And last but not least, always positive. And then we square the second term, which would be c to the 4th. Okay, so that is the final answer. It does follow the pattern exactly. So the nice thing about these, despite looking a little confusing, once you've done a few of them, they become a little more clear since the pattern continues and is always the same. So we'll try more of these in class. Pause or rewind if you need to, and thank you so much for watching.